Okay, Peter, you're on.
All right, thank you. And thank you, Satwinder, for inviting me to do this presentation. This is something that's always been very important to me throughout my career, is making sure I took proper data measurements. I've done a lot of the construction of pilot plants. I've built water plants and wastewater plants. And if you don't have proper data on how the process is operating, you have no idea what's really going on in your system. Particularly, you've got lots of system that is underground, for example, and the only way you can have an understanding of how well that underground aspect of your plant is working is by looking at the data you collect in your water treatment plant. So a lot of things can be deduced from taking your data. You can figure out all kinds of problems with your system. It could be whether or not you've got a leak. It could be whether or not you've got contamination. And the most important thing is you're really trying to detect abnormal water use. If you do detect the problem when it's small, you can often prevent it from getting bigger, and you can prevent your community from running out of water. If you can detect a leak while it's still small, you can locate it, hopefully, and fix it before your reservoir runs out. Generally speaking, you're going to have 2 to 4 days of water in your reservoir, but that's under normal use. If you've got a leak, you can lose that water very quickly. And of course, the primary goal here is to protect the water, protect your community from any waterborne bacteria. And if your system's not running correctly, or even if you have a leak in your system, you can add contamination to your water. So it's really important to be on top of the operation of your plant. And of course, this can save you a lot of money if you can catch these problems before they get to be big problems. And if you end up having to haul water into your community because your system has failed, that can cost a horrendous amount of money, up to $100,000 a week. So depending on your particular water plant, you may need to collect any of the following: water flow rate, pump hours from your well pump, pressure, either line pressure or pressure across instruments. Often you have, for instance, filters in your system. You'll be measuring pressure before and after those filters. That's really the best way to determine if your filters have clogged up. You'll want to be monitoring your chlorine consumption. It's really critical that you know how much chlorine you're using. For one thing, you need to order chlorine on a regular basis, but you don't want your chlorine sitting around for too long. Chlorine, as a general rule, shouldn't be stored more than 3 months. And of course, chlorine residual in your distribution system is critical, because that's really end of the line, point of consumption, where you have to make sure you've got sufficient disinfection. And also, if you've got a system that has issues with arsenic, manganese, or iron, that's something else you're going to want to be monitoring. It's not something you're going to actually do the test for yourself, but it is something that you're going to want to take samples and send off to the lab on a pretty regular basis, just to make sure things haven't changed. Manganese, for example, although often consistent in a well, I did run into a plant where the manganese during, I think it was July or August, would suddenly spike about 3 or 4 times higher and then go back down again. Something to do with underground water flow. Don't really know why, but careful monitoring meant that we could plan for that ahead of time and be on top of it. There's a lot of equipment out there now for monitoring your systems, far better equipment than we had 20 years ago. We have flow meters. We have, of course, pump hour meters. There's tank level monitors, often done with pressure, sometimes done with just floats, sometimes done with just a scale on the outside of your reservoir that floats up and down. pH meters, which are sometimes necessary in a plant. Chlorine meters are getting more common. Again, pressure sensors, which can be very useful in figuring out what's happening with your system. Temperature sensors occasionally, and of course, turbidity meters can be very important, particularly if you're looking at a surface source. Turbidity can have a dramatic change in, for instance, how often your filters plug up, and also turbidity will change the use of chlorine, since turbidity has a tendency to consume chlorine. So this is an older style flow meter, but they're still in very common use. And looking at it from the top, it's really important to take a close look at this and realize that this particular flow meter is in imperial gallons. One of the biggest problems that occurs, I think, is when people don't know whether or not they're using imperial gallons or American gallons, or whether they're actually doing metric and we're looking at liters or cubic meters. I believe one of the Mars landers didn't make it to Mars because half the team was using an imperial system and half the team was using a metric system, and somehow they didn't manage to get the conversion rates correct. So that one flying off into space somewhere. Hopefully that's not going to happen to you, because you're going to be aware of exactly what units you're using, and hopefully they'll be consistent throughout your plant. You don't really want to have units in imperial gallons and another measuring device giving you American gallons. And pressure. Pressure is another important thing to be monitoring in your plant. This particular pressure gauge is monitoring the line pressure, which in this case is actually quite high. That's 85, 90 PSI is pretty high for a system. And of course, that's an important thing to know. For instance, if you're using chlorine and you have a chlorine pump, some chlorine pumps are simply not going to be able to work at that kind of pressure. So it's a different style altogether. And also a change in line pressure is a good indication that you might have a leak somewhere. If you find you're using more water than you expected and you want to go and isolate that, if you go out into your distribution system and you find your isolation valves, which hopefully everybody knows where those are, it's extremely important to have those exercised every year and ready to go. You can isolate a section of your distribution line. You can put a pressure gauge, pretty much like this one, on that line and watch it over a few minutes to see if it's losing pressure. If it is, then that's probably the section of the line that has a leak. This is another pressure gauge. This one is across filters, actually. It's hard to tell from the picture, but that big black thing is the top of a filter. I believe that's a 5 micron. But you want to make sure you have a pressure gauge before and after your filters, because once the filter begins to clog up, you'll get a change in pressure. And it's that change in pressure that will let you know your filters need to be either cleaned or replaced. Generally speaking, a change in 10 PSI is when I would look at either cleaning or replacing your filters. This is a pretty good picture of a plant that has a lot of different meters in it. So there's the obvious flow meters, which are the big blue ones. These are actually Endress-Haas. They're a more modern filter than the old brass ones I showed earlier. Usually quite reliable. They have 4 to 20 milliamp output that will transfer the number directly to these meters above. That's why there's 2 flow meters and two display meters. But this is actually fairly similar to a lot of the setups for chemical sensors, pH meters. They'll also have the sensor actually in the pipe, but the actual readout will be on a panel above it, pretty much like these two up here. One of the things that I like to see is an actual physical place you can read it, because sometimes if your system goes down, you still need to know what's going on. And if you've got a SCADA system and the SCADA system shuts down, there might not be any place to actually read what the actual real-time measurement is. So trends, knowing what's normal. This is critical to understanding what's going on in your system. So on a day-to-day basis, your water should be, use should be pretty consistent, even if it does vary during the day. However, on a yearly basis, the water will vary dramatically month to month. Now, it's important to know what you can expect the water use is to increase and when to expect it to decrease. The highest usage is usually during the summer when temperatures are highest and people are watering lawns, etc. And of course, then the lower usage is in the colder months. But temperature is not the only reason for an increase in water use. During a fishing season, water use can spike as people clean their yearly supply of fish over a couple of days or weeks. I notice people often have a tendency to just leave the hose running. Even one hose running can be a significant draw on your water supply. So this is a pretty typical graph of your water usage over the year. In the wintertime, you've got a fairly low, consistent amount of water, but once it starts to heat up, you'll find it dramatically increases. Now, this year in Victoria, where I'm living, we had almost no rain at all in April and May, and so water use would have spiked quite a lot at that time. The temperature was up to 20 degrees, so quite unexpected. So you've got to make sure you're not just looking at this, you're also looking at this particular year's weather conditions as well. So you can make a reasonable look at how much water you should be using. So it's, again, knowing these cycles for your treatment plant will allow you to both plan your maintenance schedules and help ensure you have enough supplies on hand. It'll also let you know whether or not your distribution system needs attention. Sometimes you'll have an issue in the plant, but sometimes you'll have an issue in the actual distribution system, which is for the most part underground. Sometimes you'll find water coming to the surface that you can actually see that indicates where a leak is, but often you won't. Often there'll be no indication at all above ground that there's a problem. The only way you're going to know is if you're doing proper data measurement and monitoring pressures and consumption rates, etc. So daily consumption changes during the day, of course. There's very little consumption at 2 a.m. in the morning, but that increases to a maximum around 8 a.m. when people are getting up, going to work, and then again at 5 p.m. Of course, Monday to Friday. On the weekends, this changes, although there's still peaks. And if you're looking to determine how much leakage you have in your system, if you can get up at 2 a.m. and go to your plant and see how much water you're actually using at that time, that'll give you a pretty good indication of how tight your distribution system is. Almost all systems are going to leak a little bit, whether they're run by Metro Vancouver or run by a small community. But knowing what your baseline leakage rate is really important. And then hopefully work towards minimizing that as much as possible, because it costs money to treat water and there's no point wasting it. So this is what it looks like over the day. Again, early in the morning, very little usage. Peaks as people get ready for work. Sometimes there's a slight peak at lunch, and then again when people get home from work. When I used to work with Metro Vancouver, we worked on a lot of the sewer systems here, and the operators would tell me that you can tell when the first period of the hockey game ends because influx of sewage coming in. So people pretend to be pretty regular about these things. So flow rates. These will tell you your water consumption. And of course, it's directly rated to pump hours. And the flow rate's off of a flow meter. You can use those to confirm that your pump output is not changing. And you can see whether or not you are actually following your daily and seasonal patterns of water use. Generally speaking, your pump hours should not change much day to day because pumps have a pretty consistent rate. Now, recording your flows off your flow meter, it's not a replacement for recording pump hours, but it is a useful check on your calculations. Also, by comparing the number of pump hours to the total water pumped from the flow meter, you can monitor the condition of the pump itself. Sometimes there can be change in the level of water in a well, which means you're pumping against a bit higher head, and that'll change the amount of output you're getting from your pump. And sometimes pumps actually wear out. Propellers, for example, on pumps can wear, and they'll then be producing less water. And it's important to know when that's happening ahead of time, so you can get a well installer to come and look at your system before your pump actually fails. Particularly if you happen to be unfortunate enough to be in a system that only has one well and one well pump in each. So pump hour refers to the number of hours that a pump is running, and is usually a running total from when the pump was first installed. So tracking pump hours will give you information about the amount of water being used, increase or decreases in usage, and possible leaks. And again, whether your pump is running as it should run. So the calculations of how much water your pump is producing is pretty straightforward. Your pumps, generally speaking, if they're running against constant pressure, which if you have a reservoir, they usually are, you can figure out by how many hours a day, how many liters per second your pump is producing. You can easily calculate how much water you're using every day, which you would then be able to compare that directly with the amount of water used on your flow meter. And again, if you're pumping against constant head, like into the top of a reservoir, pressure is not going to change. The pump's production should be the same at a constant, in this case, 20 liters per second. If you're pumping into a community without a reservoir, like a very small community where you just have a small number of houses and you've got a pressure tank, that's going to be a bit more difficult to monitor, but it should still be reasonably consistent, because your pressure then is usually just changed from, say, 40 to 60 psi back and forth. So generally speaking, you're still going to end up with pretty much the same consistent numbers. And of course, you can use the data from your flow meter to monitor the same things that you're monitoring with your pump hours, but the two are a very good check on each other. So again, very, very useful to be tracking your water consumption. It's the only way you're going to know if there's a problem. When you see that your water usage is outside of the expected daily or yearly trends, again, because you're going to be increasing your production during the summer, you can often deduce the source of the extra usage by the way the water use has changed. So examples. If your daily pump hours suddenly spike up and stay up for several days, this could indicate a new leak in the distribution system. Now, the distribution system, by the way, isn't just the pipes in the ground. It also includes all the water systems in each house. If somebody has a broken toilet and it's running water, that can add, you can definitely notice that in your distribution, in your amount of water used. And if you have several people where that's happening, you can waste a lot of water. Now, if you find that your daily pump hours are increasing over several weeks, it could be that your pump is failing, or it could be a slow leak getting bigger over time. And that definitely happens. If you have a pinhole leak in a line, often it'll be a line that's going from a curb stop to a house. That can start small and expand slowly, and then often expand quickly after that. Often brass fittings, for example, if there's a pinhole leak in a brass fitting, it can wear dramatically over time and end up with a huge leak. So again, having a flow meter is a very good check on whether or not you're actually pumping more water in this scenario, or if the pump is working harder for some reason. So again, this is what a graph of a sudden change might be. One day you're pumping 5, the next day you're pumping 10. Doesn't really matter what the units are. It's really the change that matters. And of course, if you find a sudden change, you really want to go and check your community to find out what's happening. Has somebody been doing some excavating? Is somebody trying to install a new curb stop that you're not aware of? In fact, that's, I think, one of the most common issues is somebody breaking a line or attempting to tap into a line. My view is that if anybody's digging a hole anywhere in your community, you really should be out there to make sure they're not hitting one of your water lines. Again, that's another good reason to make sure you've got all your isolation valves located so that you can isolate a leak quickly and have it repaired. So a gradual change is going to be more like, that's funny, Wednesday's a bit higher, Thursday's higher again. Now you know you've got a problem somewhere. You still have to now figure out what it is. But it's probably not from an excavator breaking a pipe. It's more likely to be a leak in a house, leak in a curb stop. Chlorine is incredibly important. This is what we use to make sure that the water entering everybody's house is completely safe to drink. So chlorine is by far the most common system of disinfection on small systems. And tracking your chlorine consumption is particularly important in keeping an adequate chlorine residual in your distribution system. So measuring the amount of chlorine consumed daily will let you know if you have a problem with your chlorine system, I will also let you know when you need to order more chlorine. Again, I think I mentioned earlier, chlorine really shouldn't be stored for more than 3 months. So it's good to make sure you can order it on a regular basis. So common problems with chlorine systems are you get an airlock in your line. And this is actually quite common, particularly if in the design of your plant, someone's run a very long line from the chlorine pump to the injection point. Chlorine pump failures often happens as well. These pumps really are only expected to run for about 5 years. So it's good, keep track of your pump, have a repair kit on hand if you need, in case you need it, but also plan to replace your pumps around 5 years. It's important to catch these failures before the chlorine residual in the distribution falls to a dangerous level. If you've got a couple of days of water in your reservoir, that gives you a couple of days to fix things. The reservoir is well mixed. If you start putting chlorinated water back in again, you can bring the chlorine level in your water back up to a safe level pretty quickly. The other thing that sometimes happens is you can have an injection point that will clog over time. And again, if you happen to have a pressure gauge on your injection line, you should be able to see that too. So this is a fairly typical one pump chlorine system. Most chlorine systems will have 2 pumps these days. Sometimes they run alternately, and sometimes one is just sitting aside as a reserve, which is what I tend to prefer. If you've got 2 pumps running alternately, you can run into a few problems. The obvious one is that although they'll last longer, they'll both fail about the same time. But also, if one pump is faulty, it can be very difficult to determine what's happening. I worked on a system where we had a brand new system. We had 2 chlorine pumps, but our chlorine residuals were incredibly inconsistent coming out of the plant. And it took a while before the circuit writer in this case figured out that one of the pumps was completely faulty. And once we figured that one out, we were able to replace it and get the system running properly. Now you can see the tank at the bottom of the screen with the red lid. That's the actual chlorine tank. And on the side of that tank, there's numbers. And if there's not numbers on yours, then I suggest you put some tape on there and put numbers on there so you can monitor the actual levels in the tank. One of the systems I worked on, the operator would look into the chlorine room every day when he went into the plant. Usually it's going to be separate from the rest of the plant with a separate door, because you don't want chlorine gas getting anywhere near your electricals or anything else in the system. So usually they'll have a separate room and there'll be a window between the 2 rooms. Of course, safety, in case somebody goes into the chlorine room and passes out, you can see them. But also it means you can look through there to see if your system seems to be running fine. So he would look through the glass. He'd see that the chlorine pump was running and he'd go about his business, but he wouldn't go in and actually look to see how much chlorine was being used. And of course, the problem was the system was airlocked. And for about 2 months, I think, he didn't bother checking it to see if it was actually using chlorine. And it ended up they had a serious bacterial problem in that system, and that whole community had to be evacuated for a couple of weeks while we went in the middle of February to flush the lines, clean everything out, rechlorinate the reservoir, chlorinate the well, and try and get that system back up. That cost well over $100,000. That was completely unnecessary. All he had to do was go in, look at the tank, or write down the number every day. I mean, and that's a huge expense. That was completely unnecessary because he just failed to do really the most basic monitoring of the data, which he had. It was there. So monitoring the residual in your system is also critically important. And in the case I just mentioned, had someone been actually doing proper residual measuring, they would have discovered that problem as well. But in that case, they had different people monitoring the residual than was actually running the plant, and they were not communicating. So if you're running a system and you're getting residuals done throughout your system, it's important that you know as the operator what those residuals are. so that you can look at that and determine whether or not you're running enough chlorine into your system or not. In fact, often what happens when you start a system up, a brand new system, you do a calculation, which I'm not going to get into, but it's not too difficult to figure out, roughly speaking, how much chlorine you'll need in your water in order to give you the recommended 0.2 milligrams per liter of chlorine. In most systems, that's pretty straightforward, but depending on the chemical composition of the water, that can change. So you do a calculation for that, but it's basically an estimate because you really don't know what's in your distribution system that might consume some of the chlorine. So you make your best guess, you set it up, you start running the system, and then you start testing for residuals, because that's the real important factor. Is at the end of your line, are you getting the 0.2 milligrams per liter of chlorine in that water that you need to ensure that the water is safe to drink? And if you're not getting enough, then you slowly increase the amount of chlorine you're putting into the water, and you monitor that over time, and hopefully you will slowly build up to the point that you'll get the right number. But of course, you don't just test one place. You test several places within the community, as well as testing in the treatment plant itself to make sure you're putting in a known amount. And of course, once the system is tuned and running, it's again important to know what your normal readings should be, what you can expect. So if you're getting residuals throughout the system, you'll know that down one road, you're likely to get numbers that are 0.3. The other road, you're likely to get numbers that are 0.18 or 0.19 or 0.2. So you have a sense of what's going on. Again, so if you have a sudden drop in your residuals throughout your system, it's an indication that your chlorine injection system is not functioning properly. However, if you have a drop at just one point in your distribution system, or from one point farther on, that's an indication that you might have a source of contamination actually within your distribution system. And I've run into this several times. We are working on a plant that had a new, actually it was an old system, but they put in a brand new sixplex, and we could not get a good residual out of that system. And we ended up getting bacterial out of the system as well, right at the sixplex. So eventually what we ended up doing is we dug up that pipe, pulled it open, flushed it out, and some kind of small animal came out of the system itself, actually. So somehow during the installation point, something had crawled into one of the pipes. It wasn't checked, the pipe was sealed up, and we had this poor drowned animal in there contaminating the water. And that's actually not that uncommon. If pipes are left on the ground, creatures will sneak in there. Somebody else I know was working on a system and same problem. They had low flow, lots of contamination. So the guy decided, well, I'm going to flush this section with the hydrant, cracked open the hydrant, and I think it was a dead raccoon that came flying out of that hydrant. So yeah, you can't put enough chlorine into a system to deal with a problem like that. You've got to figure out where that point contamination source is. But also this distribution system, checking residuals, it's also important when you do your tests for other things as well. Generally speaking, maybe once a year, you might go through your system and do tests for metal contamination. If you have a system that's not really prone to that, you're probably not going to be a problem, but it's still a good thing to test. And one of the systems I worked on, we had a big panic because they found lead in one of the samples at one of the houses. Now the system had never had a problem with lead before. None of the other sample points had lead, but there was a big panic now because of course lead's very toxic, particularly for children. But of course, it turned out that because it was only at one point, we knew that the whole system was not contaminated. We took a very close look at the house that the lead showed up in and realized it was an old water heater that they had that was somehow leaking lead, probably from issues with the solder in those old systems. So again, because you know your system's good, you find an indication of lead, you can isolate that down to go, okay, this is not a distribution system issue, this is a house issue. So what is your data telling you? So in broad terms, your data will show you when there's something in your system, when something in your system has changed. A closer examination of that data will help you identify what has changed and lead you to find the cause and help you troubleshoot your systems. For example, as I mentioned earlier, I think water turbidity can change during a particular time of the year. Sorry, that was poorly worded. Surface source in particular can change in turbidity, and that can affect the amount of chlorine that you're using, and again, then lead to a change in your residuals.
So like 830? So
now checking your chlorine system. Again, if a less than normal amount of chlorine is being consumed, given the amount of water used, which you can determine by comparing your daily chlorine tank levels over time, you want to start looking at the chlorine pump. Is it running? If pump appears to be running, check for airlocks in the chlorine line, check the injection point, make sure that that's flowing properly. So water flow rates. Now in a non-flow paced system, you want to check your flow rates. Has the flow rate changed more than you would normally expect, given your daily, yearly expected consumption? If your flow rate increases, you want to make sure you compare that to your pump hours to see if you've got a corresponding increase in pump hours. And does the level indicator on a reservoir indicate that there's an overflow condition? I've had people basically have issues with their controls. Often in some reservoirs, you'll have float controls that just turn on the pump and turn it off depending on the level in the reservoir. And when that failed, the operator decided he would just turn his pump on 24/7 and let the water fill up the reservoir and then overflow. Okay, not the best solution to that problem. Again, now does that reservoir level indicator match the actual level in the reservoir? Not a bad idea to climb up your reservoir every once in a while and take a look just to check to make sure you are indeed getting an accurate read there. And again, if the flow numbers are actually higher than normal, you want to figure out what could account for this increase in use. Again, are people filling pools on a hot day? Are people canning fish? Or has, again, been some construction near the distribution system that could have caused a leak? Sometimes it's a matter of, like I said, excavator actually hitting your line. And sometimes it's just the excavator could have loosened pipes underground. I had a system where we would test the hydrants for flow. We would test for instance, static pressure when it's just a pressure gauge on your hydrant. Again, as I mentioned earlier, which you can use when you're trying to find leaks between isolation valves. And then we would turn on the hydrant and check the pressure and get what's called a dynamic pressure. And there's a ratio between these two things. And we found that although the static pressure was good, the hydraulic pressure was low, so the dynamic pressure was low. And we had no idea why that was the cause. But I think about a year later, we found that they had a leak in the line after we had run some swabs through the line to clean it. We began digging around and finally found the cause of this. And what it was the line that we had in the ground, even though it'd been there about 20 years, but it looked like when they were burying the line, somebody with an excavator had actually hooked the line and kinked it. But he didn't kink it enough to pull it out of the pipe in front of it. So there was no leak at the time. But what it meant was that the gap in that pipe was narrowed down to about half of what it should have been. That's why we didn't get the dynamic pressure coming out that we really should have had, given the size of the pipe. What our problem was when we ran swabs through the system, and swabs in this case are basically big sponges that we just push through to try and scrape the sludge off the walls of the pipe. They had to be forced through that gap, and that was enough extra force on that line to pop it out of the pipe in front of it, caused a big leak. So that was something that should have been caught when they buried the pipe. You never know. Once it's underground, you can't really see what's going on. And you have to rely on things like, in this case, the change between the static and dynamic pressure to figure out that there's a problem. So recording your data, this is critically important. So how you record your data will make a big difference in how easy it is to know what the data is telling you. So the actual numbers are less important than the difference between numbers to tell you if your plant is running outside of expected trends. So you want to use a spreadsheet that automatically helps you do basic calculations and plot trends to collect your data. And when collecting data by hand, using a well-configured paper sheet, leaving spaces for calculated numbers. So this is really important because everybody's plant is going to be different. So I'm not going to give a general recommended spreadsheet for this because again, you really have to do it yourself. So this is an example of a spreadsheet, and it has some good points and some bad points. Again, it's strictly there for this particular plant, but you can look at it and you can see that there's definitely some issues. And just by looking at the spreadsheet, you can see something about the plant itself. The fact that it has an inlet pressure and an outlet pressure, well, it's an indication that they've either got filters or in this case, they've actually got a softening system. And if you look on the notes on the side, you'll see it's got bags of salt. Those are things that go into softeners, so that's a good indication of what's happening there. It's also got his chlorine concentration written down, which is good to have. And in particular, he's got chlorine solution tank levels, and that's again really good. He's monitoring that every time he's in the pump house, which is not, as you can see by the date, every day, unfortunately. And he also puts in when he fills it up and what he fills it up to, so that he has a pretty good sense of how much chlorine he's using on an ongoing basis. But he doesn't really have a place to put the change in the flow meter number in order to tell you how much water has been consumed between those two sample dates. And again, same thing when he looks at his pump hours. Doesn't really have a place to indicate how many pump hours has been pumped. The pump pumped that between those two sample dates, and really another line to say how much how much flow is going out of each of those pump hours to tell you whether or not everything's functioning as it should. So this is again a flow meter from a very simple system. I think all they have here really is a flow meter. And again, he really all he does is write down these numbers, and then he just tries to figure out his numbers on the side. But it's not really set up very well here because he shouldn't have all these other numbers trying to cram into his cubic meters calculations here based on his time. And you'll also notice he's got some fairly inconsistent visiting this pump house. This is another one we're going to look at. I like the fact that he's got weather conditions. That can be, again, quite useful to help you explain any large day-to-day changes. But again, he's got problems with his hour meter and his flow meter. He's trying to do his calculations and he doesn't have anywhere near the space to do that. And it makes it quite difficult to look at your spreadsheet and go, oh, look, my daily consumption is increasing, my pump hours are increasing or not decreasing, or hopefully you want to be able to look at it and see that everything is consistent. Excuse me. Because if you see a string of numbers where everything is, say, what has it got here? It's hard to read, 4.28, 3.5, 5.7, and kind of look at, you can get a sense that every day he's got a number that's fairly consistent. But if you look at the time that he takes his samples, he's got 10 in the morning, 3 in the afternoon, 11:30 in the morning, 2:30. You actually go out to your system and take your measurements, say, at the same time. Then you don't have to adjust for the hours in your calculations, and it's much easier to quickly figure out how well your system is doing. Definitely, I would recommend, if you can, go do your measurements every day at the same time. and then it quite easily shows you exactly what's happening. And here's another system. So he's got the chlorine tank, which is really good. Shows you exactly what how much he's putting in. But again, no calculations on actual volumes used every day. I mean, chlorine pump speed is useful, especially if you're just starting up a system and you're trying to gauge the end result from residuals in your system to how much chlorine you're putting in which case you might start with 2.8. A few days later, go up to 2.9, see how your residuals change. And that way you can zero in on exactly the right setting, which again, you want to monitor over time because that could change as well. The last thing I wanted to talk about was just SCADA systems. And so it stands for System Control and Data Acquisition. So most new sensors will have an output that can be sent to a project logic controller, so basically a computer. And it sends a 4 to 20 milliamp DC signal. So these systems can be quite useful. They will automatically log and graph data. They can also be used to control various parts of a water plant. Personally, I think they're best used just for alarms, emergency shutdowns, and then to look at data. But I'm not, for a small system, I'm not 100% sold on these, particularly the control aspect of them. Acquiring data is good, and especially the graphing. It's really nice if you can go in and just look at daily usage, monthly use, yearly use, and just see how things are going. There's nothing better than a visual graph to indicate how consistent the system is working. But there's problems with them too. They are expensive. And often if you need to make adjustments, you need an expert to come in, and the cost of bringing an expert in can be extremely expensive. If you have a problem with one, if something fails, who can you get to fix it? I mean, if you're in Fort St. John, I mean, how many experts do you have on data control up there that can come out to your plant, analyze it, and fix it? Can they do it today? Can they do it next week? And often when they put in these systems, they will take out the actual manual read on a lot of the meters. I worked on a system where all the data collection points were fine. The pressure sensors, the flow meters, the pump hour meters, all these things were working fine, and they all sent their signals to a PLC, which you could then read the information off what's called a basically it's a screen. It's called a HMI, a human machine interface, and the screen failed. But the system was 10 years old, and we could not get another screen that would fit the system. So, and the operator is trying now to run the system when he cannot look at any of these outputs manually. So the flow meter did not have an output he could look at like we saw with those other, particularly the brass ones. The pressure sensor had no output other than going to the computer. The pump hours, again, just went to the computer. He couldn't directly read it off the panel. So he was trying to operate this plant completely blind. And again, that cost them, I think, 40 grand to try and replace that computer screen, because it also controlled all the settings and everything else in there. And often when these systems are put in, it's not unusual for the person who does the programming to put in a password. And if you don't happen to remember the password that was put in 10 years ago, you really can't do anything to adjust the system, particularly if you're adding things to the system or changing some of the controllers, or some of the, like if you change your pump, you'll need the SCADA system to know that that's a different pump, it's pumping at a different rate, etc. So that's all I had to say, but I'm definitely open for questions.
Peter, do you want to turn your camera on so people can see you?
Okay.
We address questions? Yeah.
Sure. Just, okay. There I am.
Oh, great, excellent. Thank you so much for that amazing presentation and most relevant and, emphasizing the importance of data collection and manual data collection on top of that, and how important it is to help you troubleshoot your systems, locate problems, and of course, fix them before they get larger. So that was great. So I'm going to read you the questions as they come in, and it'll be great if you can answer them. Okay. A really great presentation. I'm really enjoying it. Peter, would you be able to advise where would operator access monitoring templates?
Oh, that's a good question, actually. If you have a SCADA system, then usually there's a template set up on that system itself. But if you're doing it by hand, it's really best that you just make one yourself. You want to look at all the information you need, like the date that you're taking a sample, the time of day you're taking the sample, the actual direct readings off of the equipment you have. And again, the other thing I would say that they often don't do is make sure underneath, for instance, if you have a column for flow, you want to make sure you're right underneath there. Is this liters per second? Is this imperial gallons per minute? So that anybody else who looks at this can also see exactly what's happening with that. And again, then as you set it up, you're going to have to calculate, for instance, between one day and the next, how much flow you have. So you want to leave a column that says, basically change in flow, delta flow, and then just subtract the two and put that number there in the next column. So you want to make sure you're basically, what you have to do to calculate the flows you have and your daily flows, and make sure you leave yourself space for that. I didn't give a standard one because it's so dependent on your own plant that it's important that if you can write it yourself, you're going to have all the columns that you need.
In fact, that very first slide tells you some of the process measurements typical plants take, and then you can definitely kind of build it based on that too. It would be a more sort of a generic one, but having a specific for your plant is the best template to develop. Okay. Do you have an example of a manganese distribution plan?
I'm not sure what you mean by that.
Yeah, Darnell, do you mean like checking for manganese because you've removed a manganese, or is it just manganese monitoring in your distribution system? So if you have a treatment plant, you would monitor the manganese after you have removed it. But if you're looking at as a nuisance aspect for manganese, then it would be, we usually don't check for manganese in distribution system.
Well, it does depend. If you have a system that has had manganese and you have manganese treatment, then yes, on a regular basis, you're going to be checking the level of manganese, hopefully coming out of your plant and in various places in your distribution system. That's the only time I can think that you would want to do that. And you want to do it basically several locations. Sometimes manganese will settle out in a water line because it is fairly heavy as a metal. And if you've got, for instance, a long line that doesn't get a lot of use, you can sometimes have manganese settling out in that, in which case you really want to be flushing your system on a regular basis to make sure you flush that out of a hydrant somewhere and not let it get into someone's house. If that's helpful, I hope.
So if you're treating for manganese, do you still check for manganese residuals in the distribution system?
Yes, you do. Yep, you still check. Yeah,
Okay.
it's a good idea to check, particularly if you just put in a new system. you want to make sure that you're getting the treatment that you hope you're getting. But then on an ongoing basis, you want to make sure you're checking, because manganese treatment systems can fail. They're dependent on, for instance, the amount of chlorine you're putting in, because the chlorine helps with the oxidation of the manganese, having it attached to the media. And if your chlorine system goes down for a while, you can definitely get a spike in manganese in your system, because it's the manganese removal system isn't going to be working very effectively.
Thank you very much. From Darnell, we're being asked by our health officer for a manganese distribution plan. Our manganese is still within maximum allowable concentration, but has increased, although still within the maximum allowable concentration allowed. So their manganese has gone up within the distribution system.
So again, I would suggest they're looking for you to come up with a plan about, just to let them know where you're testing and how often you're testing for that, so that you can track, which again is the whole thing about doing these data collection, is you can track any change in the amount of manganese in your distribution system. But if you've got a well, which I'm sure you do, because that's where manganese comes from, you want to be checking your source as well. Make sure that you're consistently monitoring your manganese actually coming out of your well, because that'll help make sure you don't get blindsided by an increase in manganese at some time in the future. But I think that's probably what they're after, some kind of testing schedule.
So how many points of checks? Well, depends on how large your water distribution system is. So let's say within a 500 people service, how many monitoring points should you have for manganese in a distribution system?
I actually don't think you'd need very many. Okay. I would test raw water coming out of your well, and assuming you have no treatment. Okay, if you have treatment, then of course you're going to test after the treatment as well. But your raw water, and then if you can get the water coming out of the reservoir, that's a good idea too, because there's some oxidation in there and you'll lose manganese in your reservoir, which means of course you have to clean your reservoir a little more often. And then I would choose just a couple of places in your distribution system, just to make sure when it actually is getting to people's houses farther down the line that you're also good. And these are things you send off to a lab. I don't know how often they would want you to do the testing. I can't imagine it would be more than monthly if you're already under the limit. Manganese is the limit's quite new, because really it's a cumulative effect from manganese. It's not like you get a couple of bacteria and you can get very sick. It's manganese is a danger over a lifetime of accumulation of use. So if you pop over the limit once, it's not going to actually hurt anybody. So I would think monthly would probably be fine.
Next question, Peter, do SCADA systems require scheduled regular maintenance, and would that be covered by Indigenous Services Canada funding for the First Nations communities?
Yeah, SCADA systems, it's more a matter of maintaining your sensors. Again, if you've got a chlorine sensor, HP, anything like pH, sorry, anything like that, that has to be calibrated on a regular basis, but that should be covered from your maintenance funding. I believe last year they increased the expected maintenance funding from 80% to 100%. So there should be money within that. But if you're bringing in somebody to do any kind of service or upgrade on your SCADA system, that would probably be the band's responsibility. But if it's not critical, I would suggest you, when they do a acres inspection every 3 years, make sure you point out to them that you would like someone to come in and review your system, make sure everything is working as it should be, in which case they'll put that down on the list, and then Indigenous Services will cover that. Okay. I can't make them cover it, but I'm pretty sure they'll cover it.
Just going back to Darnell's question on manganese. Darnell, I hope Peter was able to answer that. I thought that was a good answer. Checking your raw water, checking your treated water, checking the reservoir, and then having a couple of testing points within your distribution system. I hope that helped. I thought that was an excellent start. Next question, Peter. Jay asks, can you recommend a simple pump runtime meter?
There's a lot of meters out there. If you're looking at pump hours, there's a lot. They're pretty standard, they're pretty basic, and they're actually not that expensive as well. If you're looking at electrical panel in your pump house, if your meter's gone, basically take a look at the one that's there and just get a replacement for it. Because you want to make sure you've got something that's the same size. I think it's called DIN. I can't remember what it stands for exactly, but make sure you get the same size. It'll fit in the same hole inside your electrical panel. If it's an old panel and the meter's old, there's probably an upgrade for that will that your supplier will know about and be able to recommend to you that you get this one instead of that old model.
Shakti asks, hi Peter, we have a small system and we do chlorine testing with the powder packets and the test tube kit. Is there a chlorine tester that is more efficient and cost effective? We looked at the HACC website but couldn't find one just for chlorine. Thank you.
Yeah, HACC has a pretty good chlorine tester for sure. It gives you good numbers. I'm not sure if I think because of the way these meters work, the fact that they could do more than chlorine is kind of a byproduct of the way they work. So I don't think it's so much of an issue that way. I don't know if you can get anything that's cheaper and smaller than that. That is a good question. Satwinder, do you?
Yeah, over time we have found that HACC products are the best, the HACC field meters. I would recommend just a meter that tests only one parameter. When you're buying a meter that tests multiple parameters, they're difficult to calibrate and sometimes the readings aren't the best. So I would recommend, I definitely recommend HACC. But getting a meter that only tests one parameter at a time would be best. And they are price-wise, they're about all the same. It's difficult to get away or finding a cheaper meter. They're about priced pretty consistently by the different manufacturers. That's what I find. So. Darnell said that thank you, that information about manganese testing in the distribution system helped. We will be providing a copy of the slide. Yes, we will be providing a copy of our slides and the recording that can be found on this webinar. Probably by tomorrow, it'll be all posted. So. Thank you for your great presentation, Peter. It relates to what water system operators deal with on a regular basis. Diana asks, if you have multiple sources and some exceeding max for manganese, it will be recommended to check the manganese within the distribution. So that's just a comment. Arvid asks, I noticed on the log sheet examples, no one was monitoring water level in the well. I would think this is a critical data to monitor. Maybe they were a surface water. Peter, you want to kind of?
Yeah, that's a good question. I always recommend that you have a pressure sensor in the well to monitor the level. It's, for the most part, it's not that usual that you lose your water, but it does happen. It depends on the well that you're running. Some wells will indeed seasonally change in the amount of head you've got in there, or the level in the well. So generally speaking, yeah, there will be a sensor that indicates the level of the water in the well when the pump is not running. so you have a good sense of that. And again, if I wouldn't be opposed to writing that on your spreadsheet as well. In fact, you can have multiple spreadsheets if it makes it easier, for instance, example, to focus on pump issues, chlorinator issues, that kind of thing. Just so you have, for instance, two clipboards so you make sure you have enough space to easily write down all those numbers. But yeah, I would always recommend that a level sensor is put into a well for sure.
Yeah, and then also the focus of our presentation was process measurements, so that's why we didn't cover, collecting the data from the well. But of course, it's all part of right from the beginning of the treatment source to tap. Process measurements are, of course, highly recommended and should be done. We just focused for this presentation on the process itself. That's why. Okay. Mark asked, Peter, you have experience in working on First Nations drinking water system. Are you aware the First Nation drinking water settlement that has $6 billion set aside for infrastructure upgrades? And can it be applied to water systems that are not on First Nation land, but that have First Nations living in the community? It is applicable to any First Nation status person not living on reserves that is served by water systems on advisory for 1 year or more between November 20, 1995 and November 20, 2021. But how can this be applied to a community water system that has Indigenous peoples living, but it's not an Indigenous community?
Yeah, I'm a year out of date now, but I believe that they're only looking at people who live in First Nations communities on reserve land. I think that's the focus. I know the focus has been getting broader over time. Originally, we were only looked at communities that had at least 5 houses, but over time they've dropped that down now to people who have only 3 houses, or even occasionally individual houses. So I know they're getting broader and broader, but I don't think that amount of money they're talking about applies to people who are not living in First Nations communities. Because of course, First Nations communities are not the only communities that have water advisories. In fact, in a lot of places, other small communities will have as much or more advisories than the First Nations communities living nearby, depending on the funding, depending on the maintenance, and just depending on the conditions in those communities as well. So I can't really answer about the compensation that they're looking at for people who are on long-term advisories. That's actually a separate part of the Indigenous services than I worked in. I worked on the capital assets side, where we actually worked on construction, but the more, I guess you would say, political side of things was handled by another part of Indigenous services.
Okay. Thank you, Peter. Brian asks, thank you for the presentation, Peter. We're looking at a remote monitoring system such as FlowWorks. Could you suggest sources for the sensors, PSI, flow, and temperature?
I didn't hear that, Satwinder. Could you say that again?
Sorry. A question is from Brian. He says, thank you for the presentation, Peter. We're looking at a remote monitoring system such as FlowWorks. Could you suggest sources for the sensors, like for PSI, flow, and temperature?
Oh, there's a lot of places out there where you can get really good quality sensors. I don't really know brand names per se. It depends where you're located as to who you'd want to deal with, but I couldn't really recommend any place in particular. There's just quite a few places out there where you can buy these things.
Okay. Our online milliamp chlorine analyzer does not hold calibration for longer than 8 hours. We use our HAC chlorometer to rely on an accurate measurement. Does iron and manganese interfere with calibration?
I think it does. I've not used these online chlorine meters myself very often. Generally speaking, I found they were more trouble than they were worth, but they have been getting better from what people tell me, and some people are very happy to have them. But I think you're right. I do think other elements will interfere with getting an accurate measurement. And again, I do believe there are things that need to be calibrated quite frequently, but I'm not all that familiar with them myself. As a general rule, in small systems, I found they weren't necessary. But again, that depends very much on your individual system and how it's set up and controlled. I would not like to use one of those, for instance, to control my chlorine pump as to how much chlorine is going into the system. I'd rather count on it being controlled by the actual well pump, so they both come on at the same time, set a constant number of set on your chlorine pump, so you've got a constant supply coming in for a constant amount of water, and then use the fact that you've got a residual downstream as the most important way to determine whether or not you're putting enough chlorine into the system. A chlorine analyzer, maybe it could be used as an alarm. If you've got no chlorine in your system, in your pump house, it could let you know that, oh, something's failed. But that's about as far as I think I would go to use one of those things.
Jay shares, I just tried Henna chlorine pH test kit. Both optical and visual, I find HAC is better. So yeah, and that's been our experience. Like mostly we buy student grade equipment for our labs, and we just find we have found over time that buying directly from HAC is the best rather than going through other providers, because they usually buy from HAC for you. So they're sort of the middle broker, and we found HAC to be more durable and so on. So, but that's for student grade, not in a treatment plant. Peter, as we wait for more questions to come up, do you want to a little bit talk about, you mentioned how hydraulic pressure and dynamic pressure and static pressure varied. I've sort of forgotten how you were discussing it during the presentation, but you want to kind of talk about how you troubleshot that, what happened, why you were seeing more a dynamic pressure rather than the other pressure that you might be monitoring.
Okay, let's see. I'll see if I can find. I have a picture that should explain this. I can find it. Hopefully, I won't lose you while I start playing around with things, but. Oh, no, unfortunately, I can't seem to find that picture, but
Okay.
what it was, I don't know if you know what Blue Brute is, that big greenish colored pipe. It was buried in the ground, and when the excavator was burying the pipe, he hooked it with his bucket and kinked it. So just think of a straw that you've kinked a little bit, and how the kink then closes off some of the open area within the straw. That's what had happened. And we knew there was something wrong because we went to a hydrant and we measured the static pressure. So no water flowing through the line. It'll tell us then the pressure in our line, pressure that's basically going to be delivered to the houses in the area. But then we put on it's a special pressure meter with a cone, and we blow water out of it. And that'll tell us what our dynamic pressure is, as opposed to the original static pressure. And that should be a particular ratio to the static pressure. And it was significantly lower than we expected. So we knew there was something going on, but of course, that kink was buried in the ground, so we didn't know what it was. And it wasn't until about a year later, I think, I was cleaning the line. So we dug down to the line up by the reservoir. We put in what's called a launch point, which is basically a big Y in the line. And we stuffed big sponges down that line. So I think it was a 6-inch line. So we put in 8-inch square sponges, force them through with water pressure, and they will then expand in the pipe and scrape all the scum that forms on the inside of your pipe off. And when we did that, we ended up having a leak in the system afterwards. because what happened is that sponge tried to get through that kink in the line that was only open about 3 inches instead of the 6 inches it should have been. And so and we put in multiple sponges to make sure the walls of the pipe are very clean. We managed to bang into that and pull the pipe actually just slightly out of the bell end of the other pipe that it connects to. And so we had water spraying out between that joint. And it was only by finding that finally surfacing. It was, I think, February, so the water it was snow on the ground, and we find a spot that wasn't frozen. So we dug it all out and found that pipe. It's a complete error on the part of the installation. And again, we knew there was something wrong, but there's no way we could locate it until that actually happened. If that clarifies that a bit. I'm sorry, I can't find the picture. I know I had it here a while ago.
I'm just going through the questions. Okay, we don't have any other questions. So Peter, I will thank you for doing this for us. It means a lot to small water systems to hear from experts and and offer real-time solutions for them. So it means a lot to us and all small water system in British Columbia. Thank you for everyone for attending, for your questions. Please email us at Online Help Center. If you have other further questions, we will relay them to Peter, and we'll make sure that we get back to you with the right answers. Your certificates will be automatically emailed to you, so please remember to save them because we are not able to reissue them after that. And then you can submit them to EOCP for your CEUs. So this was our last webinar for 2023. We'll be launching our schedule for 2024 webinars by mid-December. And then our first webinar for 2024 series will be in January. So please keep a close eye on the website for that schedule and then registering accordingly subsequently for those webinars. We are developing quite a bit in terms of course delivery as well. So our webinars will continue. And then of course, we will be launching some courses that will be available to everyone for free. Those will become available slowly over time. So please keep an eye out for those as well. We thank you for coming to the webinar, and we look forward to having you back again when we start our 2024 series. Thank you very much, Peter. Thank you to our online support system, and thank you to all the participants. Actually, there is one more question, Peter. This question is from Mark. Is the CT calculation for chlorine contact time to get the 4 log only done when a system is set up or changed? And is there an online calculator we can use where we just plug in the parameters to get the CT number? Did you hear that question, Peter? Oh, okay. Peter just lost sound. Mark, maybe we can get back to you on that question. I will post it to, if you give us your email, we'll make sure that we can get back to you on that questions. But usually your contact time is set up during the design of your water treatment and design of your clear well system. And then if you make any changes, you do have to then recalculate your CT. We can definitely send you a link to the CT calculation or how to calculate that CT. We can definitely send it. But if you just email us and the Online Help Center, we make sure that we'll get back to you. Okay. Otherwise, Peter has lost sound and he's not able to answer your question. Okay, and the email can be sent to info@smallwatersystemsbc.ca. Thank you very much, everyone. Bye, Peter. Thank you for everything.
You're welcome. Thank you. Bye.
Oh, do you want me to read that question to you again so you have sound back, Peter?
Okay, give it a try.
Okay. So is the CT calculation for chlorine contact time to get the 4-log removal only done when a system is set up or changed? And is there an online calculator we can use where we just plug in the parameters to get the CT number?
Say that once more.
So they want to know that your CT calculation is it set up when you design your clear well? And then if you make any changes, do you have to recalculate the CT? And is there somewhere they can go where they can just plug in the numbers and get the CT if there's an automatic calculator?
Well, contact time is usually calculated in advance of the construction of your plant, actually, because it depends on the water. Usually, if you've got a reservoir with a direct line to the reservoir, you've got lots of contact time. But if you don't, then you do have to make sure you've got enough residual time in the line somewhere before it hits houses. I don't know if there's an online calculator anywhere to do that. I've never run into that, actually. It's a good question. It would be a useful tool, perhaps, Satwinder.
Yes, we are developing a calculator section in our website where you will be able to do that. So it's coming. We're just working on it. Yes. But if Mark emails us, we can give him the calculation. So okay. Thank you, everyone. Again, this concludes our webinar, and we will see you again in January at our next webinar. Thank you so much. Bye-bye. Bye, Peter.